Hey, hello everybody. Thank you once again. Welcome to our day 10. Welcome to our day 10. That is awesome. Day 10 is awesome. We are almost half the way. We are almost half the journey. We started 10 days ago, not necessarily numeric 10 days, where we have introduced the course or the bootcamp, which is to prepare us for getting job, to make us a full stack programmer, ready, not an expert, but you can continue to build on whatever thing you learn. However, you'll be equipped with enough skill to interview, to start up any project, and to work in any distributed team. I mean, working remotely. So thank you again. If you have been here from day one till now, type 100%. 100%. If you have been here for just 2 days, type 20%. If you have been here for 2 days, 20%. If you are more than that, put greater than 25%. Let's do that. 100% if you have been here from day one. 100% if you have been here from day one. If you have only attended class for 2 times, just put 20%. If it's more than 2 times, just put a greater than 25%. 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 10%, 20%, 100%. Awesome. So we can go ahead and move to the business of the day. We have talked about variables. We have talked about classes, what classes are. We have talked about naming convention. We have talked about methods or functions. We have talked about how to translate a statement to functions or to methods. We have, from there, we move to data grouping, which we started with array. We dealt with array as a fixed data collection or grouping type. And then we went ahead to list as a dynamic array. From a dynamic array, we talk about sets, which provides a unique set of items. We also look at map as a way of storing a key pair item. And then I asked us to move ahead and work on the rest. Then I gave us assignments. For assignment 1, task 1, I asked us to create student records with a map by starting with a class name called students. The idea of saying students in plural is to know that that class is a collection by itself or collection by design. And so you can add to a collection, you can remove from a collection, you can get from a collection, which is why we try to add methods to the class. We have like add function, we have got get function that gets a single student. We also have a print function to print the detail of a student. Then so we cover the student, and then in task 2, the assignment I gave us, I asked you that instead of a for loop to print all the students, write a for loop to print all the students I've not seen the for loop for printing all the students. So you will need to update your class, update your class, add another method that says print all. Print all. Add a method called print all. It will have no argument because it will simply take the map collection of students and print everything. You can use list. You can use list. You can use for loop, and you can use the iterator. You can use iterator. How does iterator work? I gave you an assignment. I don't think anybody touched iterators. Let's take a look at iterators. Let's take a look at iterators. So iterators are just another way of looping through without using traditional loop or function, without using traditional loop function. So let's say we have a map. Let's say we have an iterator that has to loop through a map. So let's take a look. Let me try and see tax student. Okay, so we will have another method which is called to print all. I asked us to add a method called print all. Print all. Add the method called print all. Print all. This method does not take any argument because by default it will print the students collection. We already have student collection. We already have a student collection, so we can use the student collection. So we'll first use let's try and use an iterator. If we use say a for loop, print all for loop. For loop. To use for loop, we can just say we can declare iterator. Let me put it this way. Okay. Let me see. Let us see if you can see what I'm doing. Let's see whether you can see what I'm doing now. Okay, if you are able to see, you can just refresh. If you are not seeing my screen, just refresh your screen. Refresh your screen if you can't see my screen. Refresh your screen. Now, if you want to know all the items in an iterator, let me also refresh my screen so that we can see. Okay, can you check again? Please check again. Let's see. Okay, I think hold on. Okay, I'm trying to see. Let's see what happened. Let's see what is happening. I think I'm not also seeing from my monitor, so maybe I should retry. Let me retry. Sorry for a bit of technical hitch. That should be restored shortly. Okay, so if you are not seeing, just refresh. You should see the screen now. If you're able to see it now, type scene on the screen. Type scene, so we will know we're on the same page. Type scene. Type scene if you are there. Type scene. If you are there, type scene. So that I can be sure that we are all on the same page. All right. So we are trying to use an iterator. So we take a look at how to use iterator instead of list. Now this map, we already have students, right? So we have entries, map.entries. There is an object in map, is an internal class to map, which we call entries. So you can have map.entries, let's call it entries, equals to this dot student dot entry set. That gives us the collection. That gives us the entry set. Turns the entry set method turns the all the records in that map into a set that is unique item. There can never be duplicate in a map. Why? Do you know the reason why there can't be a duplicate in a map? Why is it that we can't have duplicates in a map? How are we sure that we can't have a duplicate in a map? Who knows the reason? If you know, please type the answer. Why we cannot have duplicates in a map? Why we cannot have duplicates in a map? Why we cannot have duplicates in a map? Can anyone tell us? Can anyone tell us why we cannot have duplicates in a map? Okay, great. That's the correct answer because it uses key, and the keys are unique to map the content or the values. Both of you are very correct. That's great. So that is why map can be treated as a set. It's a set. That is why we have an entry set. Entry set just take all the entries in the map and becomes a set. And once we have the set, we can loop through it. We can loop through it by saying we consider looping method. For the looping method, we just say for we are going to do object looping. Before we do index looping, here we are going to do object looping. And how do we do object looping? Is that you take the data type of whatever thing you are iterating. For example, in this set contains a key value pair, isn't it? Key value pair, and the key is what? Key is a string, and the object is what? Is a list, like we have done before. It's a list of string, which is the collection, right? So that is it. So we have the map.entry. Then we can now say this map.entry. You understand? This map.entries, which is a set, we can say this map.entry for map.entry, say entry or item. You can call it an item, you can call it entry, then of type from which collection entries. This object looping. This is object looping. So in this context, what we're simply doing is that we take each entry. For example, let's say we have a string now. Let me use another method. Let's say we have a list of string now, and this list of string are called say cities. Equals to say cities, or let's just say I can even declare array. Let's do like this. Say string array of cities equals to, let's say equals to Lagos, equals to London. So let's say we have array of this. and we want to loop through it as an object, we can say, instead of say for integer s equals to 0, x less than cities dot length s plus plus get index, we can simply say string. We can also say string because that is the type of the object inside the array, and then assign it to say city, then cities. So it means that we are looping through this array, and instead of saying index or cities.get or cities of index, this for loop already takes care of the index, and then we can print out the city and say, okay, system.out.println city. That's a way to do the object looping. So if you bring this method to the print all, where we have map.entries, we can also, let me move up. So when you have this, right, then you can take each item from that entries. You can take each item from entries. So that's a way of doing it. And then for each item, the key value is the object we are trying to treat, and then the value will be this string. Do you get it now? So for each entry, you can have what? You can have this. Should be something like key. So key, then value. So you can print out the key, system.out.println key, which is the student name, student number. We have student number, and then plus plus key. And then the value is a list. So, and we already have a method to print a list, isn't it? Given the student number, isn't it? So we can simply say, okay, print. However, we already have the list, so you can just borrow whatever method that is in the print method to just print the list. So we just say print value. Print value. That's a way of using the for loop. If you have to use for loop, that's a way to handle using using for loop. But if we have to use iterator, I will just move down a little. Using iterator, if we have to use an iterator, let me be sure we are on the same page. Both, but with iterator is I think it's faster because you don't have to call get index again. That's with iterator, you not have to make a second call to getting the object at a particular index, or use key to fetch the value. So that's why when you can use iterator, you can use. But when you also need to track the index, you will probably use the for for loop. So having said that, I as a person, I favor the for loop in a way. I favor. So let's look at iterator. If we are going to use the same thing using iterator method, so what we will do is that this same, we will just say we use while student, which is the map, dot iterator, or we just create an iterator. We can say iterator. An iterator could be different kind of iterator. It could be list, iterator, map, entry set iterator. So for me, the best way to handle it is that you put the iterator in a while loop. Put the iterator in a while loop. So that will be this student.entry set dot has next. An iterator has let's define the iterator here and say that iterator is an interface. Iterator is an interface, so we'll quickly go to interface shortly. So iterator map dot entry, which is the every content in that file, in that map, say k, v, which represent the key value. Then you can say iterator, and that iterator equals to, how do we define our iterator? We call iterator on this dot iterator on the set. If with the list you have before, it's just a list dot iterator. That would be iterator of the type of item you are expecting. So once you have the iterator, then I can say that while iterator dot has next, because what iterator does is that it iterates and begin to see whether there is next item within the collection. So while iterator dot has next, then we can print, we can now take the value and say that, okay, map dot entry. We say map dot entry, which is the iterator, while has next. So map dot entry, what we're expecting, map dot entry, map dot entry. What is our key? Our key is a string, and our value is a list, which is list of string, right? So when you have this, then that will now be iterator dot next. Iterator dot next. Iterator dot next. And once you have it, then let's say system dot out dot print line. System.out.print line say, or we can just like this, string student number will be equals to iterator dot get key, because it's the key, and what will be list string record equals to iterator dot get value. So you have the record, you have the value, then you can call your student ID here. We can now say student number. We have already gotten it. So plus student number. And then to print the record, we already have a method to do that. So just say print record. That's using iterator. That's using iterator. So in your class, students class, update it with a what? A method that say print all. So print all. Print all, print all, printers. Now, map has different methods. The entry set gives everything in the map, which is the entry. You understand? Which is the entry. So from the entry, you can get the key, you can get the value, right? That's from the entry. From in fact, I'm supposed to write entry here. Entry equals to iterator.next, and then this will be entry.getKey, entry.getValue. Now, if we are using list here, then here we will have entry, and then the key will be this should have been string, and then this is also list. So and then say for the first one, I'll just give a shorthand now. Say map.entry, entry, and the entries will be this.student.entry_set. And then for the value, we'll have entry.getKey, and then entry.getValue. That will give us for the for loop method, and this is for the iterator the method. So I want you to take a print all. So you have a print all. You can create different method. You can say print all for loop, and then print all iterator. So method signature, write two methods so that you will be able to differentiate between the two ways of handling collections. So you can use for loop for the collections. You can also use an iterator. Okay, so in your method, have print all loop. Then have another method, print all iterator. Print all loop, print all iterator. In the print all loop, put the method for the for loop. In the print all iterator, use the method for iterator. And then don't forget, at the top of your class, you must import java.ut.iterator. You must import that java.ut.iterator. We already have map imported, so that will help us to deal with that. Let's see. Link MP. I wouldn't know. I guess by your interest. There is always a recommendation based on your interest and what you have checked before. Okay, so let's move on. So if you have gotten the explanation so far, write clear. If it is not clear, type not clear, so that I can explain again before we move over to object-oriented programming again. Write clear if it is clear. Okay, so if it's not clear, you state the part that is not clear. Okay, iterator. Okay, like I said, there are two ways that you can get content out of collections. We have the loop, which is for loop. In fact, for loop is just a type of loop. There's another loop called a while loop. You know, that is what we are seeing in our iterator implementation. We are seeing while loop being used. So, however, before we could use the while loop, we had to, for the while loop, you have a condition. You understand? You have a condition to which the loop must continue. So for iterator is an interface. I'll soon get to interface now. In fact, that's the next thing we'll be discussing. So iterator is an interface. When we get to interface, you understand better. Iterator is an interface that has a method called next and another method called has next. The first method of the iterator called next checks whether there is still item within that collection. Each time it iterates, it deletes whatever thing that have been seen before. You understand? Just like you have a list of item, and you want to do a count, and then you start separating them from the counting. If you have used a stone to count before, or buttons to count before, you have to start counting by separating. Or let's say you are picking beans, you know, you have to, the one that is clean, you have to start separating and putting in a new bucket. So that's the way iterator works. It gets into the leaks. Yes, it gets into the leaks. Remove the one that have been seen. The one that have been seen. The one that have not been counted are the one that have not been seen. And the iterator now checks whether there is an item in the bucket that have not been seen. So that's what the has next item, because the set are arranged in a linked list. Okay, so and there is another method that it has that is called next. The has next is a Boolean expression to check whether there is an item that has been seen, but it will not delete it because you have not fetched that item. It's just like you want to do a transaction and then you want to transfer from your account to another account. What the system does first is to check your balance, isn't it? Check your balance. If your balance has enough money, then the transaction occur. If your balance doesn't have enough money, the transaction doesn't take place. So which means your account is not debited when balance check is performed. Balance check only check that there is balance, but there will not be actual debits on your, on your account. So having said that, we cannot go to the iterator. The set itself, the map itself, has a method called entry set. The entry set lists all the arrange all the item in a set. That is like a list. We have done sets when we are doing collections. So dot entry set on a map, we convert all the item to a set, and then you can do traditional loop on that set. There is another method that is called entry keys. Key set rather. Key set, map.key set. What key set does is that it lists all the keys instead of the actual content now. It lists all the keys, and then you can iterate through all the keys and use each key to get the item using map.get. Is that correct? Is that clear? So having said that, to iterate through a map using an iterator or any collection, you first call dot iterator on that item. Since map is not a list, we can't use iterator directly. So we have to get another list from that map by converting it to sets. So the method entry set that is called on the map gives us everything in a set. Or if it's just the keys you want to print out, that is maybe the matric numbers alone, then you can have key set, map.key set. Key set will give you the list of keys. Entry set will give you list of items. Having said that, you call the iterator converts it to an iterator class. An iterator class is like a list. Then you cannot call the while loop. So the while loop does not know the end of the iterator, because the iterator is not a list that you can know the index. So you don't know the index. You don't know the starting and the ending index. That's why we are using the iterator. Do you get it? And then so when you call while iterator dot ask next, that is when there is still balance in this account, then get whatever item that is next. So you now call item.next. Item.next will get the next element. Imagine that the map contains 3 items. Say map contains 3 items. 3 items. Then by the sign, for each array it will be say 0.0, 0.1, 0.2. But an iterator does not know the index. So it will first call the y.next to find out if there is anything at the starting point. If there is anything, then you call the next. So the next will take the 0th position and then move the arrow to the next position. That's how it works. So it means that the one at 0th position will be removed. Move to 1. When .next is called again, it will move to 0.2. It will move the pointer. That's what the .next does. It moves the pointer to the next item and delete the previous one, or mark it as seen. Mark the previous one as seen. So having said that, when you call .next, it will now give you whatever is in the iterator. If it is just a string that is in the iterator, then your entry here will just be a string. If it's a class of students that is in the iterator, then it will be a class of students that you will get for the next. All right. And finally, once you have the entry, which is a class on its own, you can use it to get the key. You can use it to get the value. Okay, so having said that, we can move to what we were doing previously. So that's about the assignment I gave you. I'm going to review other parts of the assignment that we need to also take care of, and then I'll ask us to write all the classes that is found. For example, for your project, I ask you to write out all the classes that are found in your project. For Saka, expect to see driver class, rider class, trip class, booking class, transaction class, car class. I'm expecting to see all these 6 classes in your repository. And for fuel, I also expect to see customer, order, item, and payment in your. If you're having any issue, post it to the group and probably respond from there, so that other can see whatever explanation I've given to the other person without having to repeat myself. Yes, so all right, good. So we can move on. We can move on to task 2. In task 2, this is this, and in our day now we talk about objects. We talk about objects, and then we talk about inheritance. We talk about inheritance. I'm trying to find inheritance, and we say inheritance is a way to avoid duplication of code. Now we also look at another stuff called it's called interface. Interface is another object oriented programming design interface. Interface provide a way of guiding. I'll put it this way: it's like a contract that you have designed that people or other developers must not deviate from. For example, let's say there's we want to build a house. We can have a building plan, and that building plan is what all the builders, all the carpenter, furniture designers, bricklayers, those are what they are going to follow. They are going to follow the house building plan. So in the same way, we can look at interface. It's like a contract of definition of what needs to be done, right? And then you cannot have implementation classes that must undo such interface. Let's look at the common interface that we can. Let's look at. Let's say we have vehicle now. We have vehicle, and then we want to have different vehicle. Yes, template kind of. Let's say we have a vehicle production. You understand? And in the vehicle production factory, we want to be able to produce car. You understand? Irrespective of the car type, we want to produce car. We want to say increase the speed of a car. Increase the speed of a car. You understand? Or let's take a working of a car and say that for this working of a car, this car should be able to increase speed. This car must be able to decrease speed. Right? And then this car must be able to reverse. That's 3, right? This car will have this certain color. And then this class should be able to start. So within the start of the car, whatever thing you want to do, that you want to power your system, how you power it, we don't know. How you power it, we don't know. So let's say have something like that. Let's say car production, or let's have an interface called car. And for this interface, we must be able to reverse. We must be able to we must be able to accelerate. We must be able to decelerate. We should be able to stop a car, right? We should be able to, what else can we do? Accelerate, then start, right? So these are the methods. So from wherever the type of car we want to build some kind of fast moving cars. Now, so can you name the kind of fast moving cars that you know? Let's say, how do you describe this? We want to do fast moving cars. We want to do fast moving cars. So we can say we have a sport car, isn't it? Which other car is very fast? Sports car. Tell me again. What kind of car do we have again besides sports car? Besides sports car. Besides sports car. What class of cars do you have again? Huh? What kind of car do you have again? Ferrari, Benz. Those are like a model. You know, I'm talking about kind of car. Kind of car. You understand? Kind of car. Ferrari is a model, it's a product of a particular company, but it's still a sports car. Sports car. What about racer car? Let's say we have a racer car. I think that one is also different. There is one you use for racing. There is one you can just it's a luxury, luxury cars. You understand? What kind of car that can we use? Let's just say let me see whether we can find an example. Let's see whether we can find an example of sports car. You can Google it and let me know. I'm not a car person. per se. Let's see. We're trying to look at different cars by. Okay, so yeah, that's good. So we have economic cars, so we have mid-size cars. We have luxury. Okay, I've talked about sports car. So we have luxury cars, and then we have electric cars, and then we have super cars. So we have super cars. Let me see. We have what we call hyper cars. I'm trying to build different kind of cars based on their speed. And I'll give examples. So we have a hypercars, and then we have SUVs, or off-the-road kind of cars. Now, so if you look at them, SUV can vary in speed based on their size and design. So SUV has like maybe by size and design. More they are on rugged terrain. Things like Jeep Wrangler, Toyota Land Cruiser, Ford Bronco. So we look at that. Then if we look at hypercars are extreme speed. Let's say for economic class now. Let's say for economic class or economic car that we are starting from. Let me put economy in the front of the list. Let's say the limit you can go is 120. Let's say the limit is 120, and then can accelerate with say the speed can get a speed of 5. So we'll start with economy. Is a low speed. Economy is low speed. So we can have a type of speed that is low. You understand? And then we say the speed is low, right? Low. For mid-size or moderate cars, these cars offer a balance between fuel efficiency and performance. So fuel efficiency, they are fuel efficiency, but they will have the same kind of speed with economy. Now, if we look at sports car, I think mid-size, right? This is mid-size. And then if we look at sports car, for sports car, it is high speed. So let's say the maximum speed here, let's say is 250, or let's say 180. No, I will say 220. 220. Let's say when you accelerate, you can accelerate with say 10 speed gain. That is for that. That's for sports car, and the speed type is what? Is high. Speed type is high. Now for racer car, for racer car, or let's go to luxury. Let's go to luxury. Luxury cars, variable speed. Variable speed. So we can put the speed at plus or minus. So let's just say the maximum is 180. Let's leave it at 180. But speed, say you can gain 5. And then here the speed is variable. Let's look at after that we have electric cars. Electric cars, zero torque, say 220. So they can gain a torque of, let's say, 20 because it's zero, but the speed is variable. For supercar, let's look at supercar. Supercar has very high speed. So let's say 280, and then the speed you can gain, let's say the gain for the speed is 50. Gains for the speed is 50. Okay, let me just say 20. Let's say 30, and then it is high. And then that is supercars. Things like Bugatti, Chiron, Lamborghini, they are all supercars. And then we have Hyper. Hyper has extreme speed. Extreme speed. And then our SUV also has a variable speed. Okay, so having talked about all these cars, with what we have here, what is common to all these cars? What is common to them? You understand? Okay, so we can also have accelerate, reverse. We can also have steer. That is the steering. So you can say steering or steer, and you can steer right, you can steer or left. You can steer right, you can steer left. So steer. So those are the actions that a car can perform. Now let's build all these cars now and make sure that all of them do not deviate from these methods that we have defined. So we first start by creating an interface, and we say public interface instead of calling it class. You understand? A class has property and could have methods and things like that. But interface, like I said, is a design guideline. An interface is a design guideline. And so you can now say, okay, for this interface, I'm going to call it car. And for this car, we will have this. We will have a method called reverse. So you define the method as if you are calling the method. So you have what return type does he have? Let's say void. All of them void. Let's say void accelerate. So accelerate, and then you accelerate with what? With a particular speed. Let's say integer speed. You see? You say integer speed, then void decelerate. When you are decelerating, you are reducing the speed. So let's say integer speed. Right. I hope we are seeing it. So decelerate. Let's say we have what else? We have stop. We have void stop. We have void stop. We have void start. We don't care how the car is started. All we know that is that when the car is started, every other thing should power up. And then we have public, we have void, because we are not getting return stop. So steer, and steer may be integer or integer direction. So we can say maybe the direction is 0 for left, 1 for right, or 1 for right, 2 for left. Whichever way, we can modify this later, and use something else, which I will quickly introduce us to. So you have a steer, and what's else? So these are the methods that have been declared. Now, the first car that we want to build is economy. So we can say, let's create economy class. So we can say public economy class. Economy car. Implement. You use implements method to create a concrete class. A concrete class is the class that can now be, worked on, that can be treated as an object or executable class. It's called concrete class. So don't forget, when we are using inheritance, we use extends. To extend the parent class. If you are using inheritance, this class will extend the parent class. But if you are using interface, it must implement the interface. So we will say implement car. That's how to public class economic car implements car. And then, so when you now say it's implementing this car, you must implement all the methods that were in the interface. Otherwise, you get a compile error. I'm going to start with economy class. So, and say that let's implement all the classes, all the methods in that class. So this one will now be public void reverse and then let's say we have when this car is started, let's say public car, everything is 0. You understand? Which means that this dot speed equals 0. Although since it's an integer, by default it is an 0. So let's say private integer. So private integer speed, and then so when we call reverse, when we are reversing, we have what we call direction. Say private direction. Let's say integer direction equals to Here direction will also be 0 because the car is on a spot. This dot direction equals to 0. Now, so when you do this, when we reverse, we can just say this dot direction. You can reverse based on the speed. This was direction minus equals to say 1. Let's say we are reversing. So that is for reverse. If we are accelerating, I think you should complete that. If you are accelerating, we have, I'm going to round up in 1 minute. If we are accelerating now, we can say this dot speed. We are increasing the speed plus equals to speed. And then that is by the speed. But because the speed gain is low, here we can say private integer torque. Let's say that is our speed gain. Let's say speed gain equals to, we define this because it's economy class, it's a low speed. Let's say the speed gain will be equals to, let's use 2 for this. Speed gain equals to 2. So which means that we don't need to specify any speed. So here, when we just say speed gain, and then when we decelerate, we subtract the speed until it is 0. Decelerate minus equals to speed gain. If we stop the car, it means that the car is not moving. If it is not moving, then the speed is 0. This dot speed equals to 0. When we start the car, everything should be what is in the constructor. When you just start the car, when you start the car, and then this dot speed equals to 0. What's when you steer? So implement this steer in this direction. I think you should finish the other method, and I want you to create Ferrari. Other supercars, public void public void void. So you take this. That's how to implement interface. So your assignment is to implement other class. I've implemented the economy class, implement electric cars, implement supercars, implement all the cars that we have defined here as an interface. This is where we are going to end it today. We'll take a look at this briefly in our next class as we move to front end. So I will push the update. Thank you so much. Thank you so much for being in class today. See you again tomorrow. Bye. Any question? If you have question, you can just put it. If you don't have question while you are implementing the assignment, just send me can send me a message at the group chat. If I attend to you, it means that others may also be able to take from you also. I can use that. Okay. All right. Finally, signing off. Clock ticking.